Hi guys, I'm back. Been a while since I made a video. I thought I'd get you a little caught up on where I'm at on this airline. So anyway, I got it pretty well wired up underneath. I still got the two coils that was going to need to be rewound. I got them rewound. They go in here. These two are okay, so they're in place. Got the main harness hooked back in and everything connected up. All tube sockets are back in place, and got a replacement caps that I restuffed in. Still got a little soldering over here, and of course, like I said again, get the coils into place. I wanted to talk a little bit about them. And something on the schematic too I want to talk about. This is basically our riders, is where this comes from. Now in here it actually has two different schematics. They're slightly different. It says model 28 below serial number 373,601, and model 28 above serial number 373,601. I think these are actually reversed. This model on this that's on the nameplate or the model plate that is actually, fastened, riveted, factory riveted to the radio, is well below 373,000. It's like 74,000 or something. I believe I showed it on one of the very first videos on this. Yet this says above that serial number. In other words, after this serial number, so definitely after this radio, that this schematic would be, you would use this schematic. Well, this schematic matches the radio. This one does not. So I think actually these got reversed. I think it's a typo. And this one is actually the early model and this is the late model, instead of the other way around. I know this for a fact is an early model from its serial number. But the interesting thing is, if you actually look at the schematic and you're following it through, and I bring it up here kind of close, here's these coils, the RF coils, right here, going through. And you just got, your basic transformers, you got your tuning capacitor, and then of course your tubes. If you come down here and you look at them again, of course the antenna one up front's here. They did a little changing right here. The early model, you just had the antenna going right into the tube, and then another RF, another RF, and another RF. But on these, if you look, they actually have an extra component, capacitor, connected across here. Now, if you go looking for that in the radio as a capacitor, something looking like this here, then you're not going to find it. And you're going to think, okay, then this schematic, even though it seems like it's fitting this, it's more like this one, because there's no capacitors on them coils. So it's got to be like this one, yet there's differences in this one, so it must be something in between. No, it's like this. I'll show you where that capacitor is at. If you take a look at the coil, it's here on all of them. Here's the other one. But the capacitor's there. And it's not hid down inside. It's actually right here. That's it. That's the capacitor. This lead, this wire, stops right here. It's just tied off right in there. Comes around and goes down and comes down inside here and comes up and hooks here, and that's hooking to that primary side of the coil, the primary right here. Now the other half, the capacitor, is actually the wire underneath it. It's part of this coil, just this right through here. So this is one plate and this is the other one, and that's all they needed. It's probably about somewhere in the vicinity of 1 to 1.5 picofarads would be my guess, but that's all they needed for that. And that's what they did, was they just took a wire, connected it to the inside coil here on one end, brought it up, and just wrapped it just above for a short distance and tied it off just above the secondary winding in close proximity, in parallel. This is one plate, and the wire underneath it, that's part of the windings of the secondary, is the other plate. So that's this capacitor, and the other two coils are exactly the same way. So I wanted to show that to you in a different form. This is actually called a gimmick, but in a different, most gimmicks you'll see in a different form where they'll actually take a wire like this and wrap it anywhere from 1 to a couple dozen turns, depending on how much capacitance they want around another wire. And but they're called gimmicks, gimmick capacitors. Now, as you can see down inside here, I've got my new coils that I rewound inside here. One's there, and one's inside here. And all I did was basically, I would have used the old form, but it was just a piece of wood and with no sides or anything. I was going to have to develop with some sides, and then I was going to have to do a little gluing or something, or slacking or something, because it's going to be several layers of coil. So I decided that I'd go a different route and use something like this. And all this is a sewing bobbin, a sewing machine. The ones I actually used in there is just slightly smaller than this. This one's a little wider this direction. The ones in there are just a little bit narrower than this. But that's all I'd used. I just used the bobbin as my coil form. Now, if you're ever going to do that, bobbins are cheap. You can buy these at Walmart. And if you need a small coil form, they're great. Just make sure you can buy these either as metal ones or plastic ones, which plastic ones are cheaper than the metal ones, which is good, because you want plastic. You don't want the metal ones. The metal ones are steel, so they introduce iron into the thing. They act as a core, and being that it's all metal up to the sides and all the way around and through the center, it acts as a wraparound core, or what they call a D-core. So it could really throw off and change drastically the inductance of your coil to a point that it's non-operational for what you're wanting to do. So plastic is better, unless your original coil form for some reason was metal, which I doubt it would be. It'd be cardboard or wood or something. Cardboard if it had a core in it. But if you got an air core, in other words, it's open in the center, and you can use a plastic bobbin. They work great for that. I didn't push the turns on it real critically. They're close. They don't have to be dead exact on these type of coils, mainly because the ones that are criticals is secondary. This is what's tied to the tuning condensers or capacitor. So it's this coil and one of the sections of the tuning condenser that makes up the tank circuit, the tuning circuit. The coil inside here is the primary side, And all it's doing, all it has, its job is to inductively couple the signal from the previous stage to this next stage that's in here. So all that primary is doing is coupling from the plate here, coupling that signal to this next stage. So it's not extremely critical, although it's not like, you know, you want to like triple the turns on it or anything like that, but you can be within 30-40% of the number of turns on it, and it will actually work just fine, especially with this decoupling cap that's on there. But so I didn't get really critical about the number of turns on it. I was more interested in keeping my DC resistance. I figured if I, you know, using the same size wire, if I keep my DC resistance, I'll stay within close range of what I need, which did turn out, it turned out just fine. So using the same size wire, everything turned out alright. But the main thing is these generally ran anywhere from, as far as a turns ratio between the two, anywhere from 6-to-1 to 2-to-1. This radio actually runs the more, I don't want to say universal, but average. The average was 3-to-1, and that's what it's actually running, 3-to-1. And so 3 turns to every 1 turn on the secondary, 3 turns primaries. So it's actually stepping down. So I'm within close proximity of that 3-to-1. I believe I'm running about 3.1 and 3.2-to-1 on the 2 that I rewound. So well within fine. It'll work just alright that way. The other change I made on here was dealing with this transformer here. What I ended up doing, since I lost the primary on here, which after tearing into this and looking at it closely, I think the reason why it got tore up, someone had worked on this radio prior. There's a 7,000 ohm resistor right here, and your B plus comes up through here and feeds in and then feeds through the coil to the plate, but this drops and is a current limiting resistor and also dropping resistor. This was switched around. The coil was actually here and the resistor was up above, so it got switched around. So the coil was actually not only feeding the plate here, well, feeding the resistor to the plate, but feeding the rest of the circuitry that going up to here to this plate. And so I think it actually burned it out because they messed with it. I don't know why they did that, but so what I did is I kept this resistor, but I added about 20,000 ohms to it in series, so I get about 28,000 ohms right through here going up to the plate, and then jumping across I put a 0.1 or no, a 0.5 capacitance in here, or 0.05. So I got 27K, well 20 with 7 on this, and then a 0.05 capacitor that couples over to the secondary to feed it. And the resistor probably, don't know if I can move this around enough so you can see it. We'll try. See if I can zoom in where it's at. Give me a second here. I don't know if you can see it down in there, but it's snuck down in there. There's that resistor I put in. I think it's actually a 22K because this 7K was just a tad bit low. And the capacitor is actually, I have to rotate you just a little bit. Right there. Sorry about the jumpiness. Okay, capacitor's inside here. I took and ran one lead around, hooked here. The other lead runs around here and hooks here. This is the secondary side of the transformer. And I just put heat shrink tubing over top of it just to cover it up. And took some wire insulation and put over the leads. That is cloth covered wire insulation. So it just kind of looks like it belongs there. So that's where that change is to bypass that primary. So that's what we did on that. Now there's something else I wanted to talk about. Oh, the other thing about the way, schematics can be drawn in a lot of different ways, and when you get into these older radios, there was no actual set standards or anything on schematics and drafting and drawing stuff. So if you actually look at a radio, okay, you got your rectifier here, and this is the cathode or the filament, and this is where you pick up B+ on any rectifier. Coming through here, going through your filter caps and a choke. So here's your pi filter right here, and it comes out, feeds up, going to the RF tubes up here, each one of the plates, and then feeds on down, comes down. They run it through the field coil as well. So, and also to the audio output transformer, where it is picked off there to feed the plates for the output tubes. Here they got this in dotted line because it's separate speaker. But when you come up here and you look at the plate, these two tubes here, this is the detector and this is the first audio. You feed back through and you come around and you come down here. Whoa, it comes down to this point. Well, what comes back? Let's come back here. We go through here, through that capacitor, and we come to ground. And this comes back here to center tab of the secondary. The first thought you may have when you first look at this, and especially if you're a newbie, is you might think, oh, wait a minute, that's a negative voltage up there, or it's ground or something. It's that's not B+. Why are they doing that? It's this capacitor right here, what you want to look at. That blocks everything, DC wise. That's just another one of the filters. Really what's going on here is that's actually just going to ground. That capacitor is coming off of here. How B+ runs is it comes down through here and goes through the field winding and comes back, still B+, but better filtered, and then goes up. This capacitor happens to be just another part of that filter, just on the other side. So really what that is, if I redraw it, and I find something to draw on here, I'll draw that out. Just give me a second here. We'll pull off and then we'll go through our capacitors and we'll just redraw them. So really what that is something like this. This is coming from the rectifier. This is that first pi filter that I showed you. This one right here. Don't get confused by how they're running these two caps. This is just a what this little cap here is for is to keep this it's a coil and it charges up a little bit. It's got ripple through it, so it'll charge up a little bit and have a little bit of discharge on it. It could spike, and that they put that 0.1 there to stop that spike. That's all that's there for. This and this is your two main filters. So this is your pi filter right here. That's the first one that I drew right here. Field winding, the next capacitor, filter capacitor, and then that runs off to them plates. So here's the field winding right here, comes back, here's the other capacitor going to ground, which is right here. And at that same point we run off and run our B plus, super filtered B plus coming up and feeding up to the first audio, coming back and feeding the detector, and then this line here, which goes down through the volume control, is feeding the screens on the RF tubes, and then the volume control along with this 70 ohm resistor here is the bias for the grids of these first three tubes. It's connected actually to the cathodes. So when you adjust you're adjusting the volume, what you're doing is you're adjusting the bias voltage, and by doing so you increase or decrease the current amplification, the amplification of the tubes. So when you turn the volume up, you adjust the bias such that the tubes are more conductive, so more signal gets through. But I just wanted to show this, how they, back in the old days, a lot of times they just start connecting stuff all which way to get to, instead of drawing a lot of ground symbols or things of that nature, they got just a few ground symbols in here, and everything else is just ran a lot of different lines and on the page and stuff. So don't ever get confused by that. If you see a capacitor and you're following DC, your B plus or whatever, and you see a capacitor in that line and then it goes to ground, well, it's not taking DC to ground. Okay, DC don't go through capacitors. Capacitors block DC. So anyway, what I thought was going to be a short video ended up being longer. I want to thank you all for all of your comments and everything. I'm sorry that I haven't gotten back to replying to them. I'm thinking about just making a video to do that. Things has been still pretty hectic, and I barely had enough time to even work on this too much. But I wanted to get this video out and show you where I was at, and show you that I do got the coils done. I was going to try to make a video of me at least winding one of them, and I didn't have time to get it set up, but it nothing complex about it. I did want to answer one comment about when I talked about the old coil winder I had. But yes, I know I could get bushings for it. I could get them made for it. I could actually get bushings that were close enough that would have worked in it. But the gears were getting worn on it. A lot of other things, the shafts was worn on it. But beyond that, at my old Altamana school, they actually have a museum in the electronics department, and I actually donated it to them. So they've got the coil winder there on display, because it's a very old one. It's from pretty much around the turn of the century. So when I got done with it, and they don't care if it's worn out, I just donated it to them. So I don't even have the darn thing anymore. But as it was, I just rigged up and just put a bolt through and put it on a drill and just slowly wound them, and kept an idea of the count and on my turns. So checked it with my resistance and made sure that both were agreeing with each other and everything. So anyway, this is where the radio's at, and hopefully in the next video we'll see it maybe playing, I hope. There is one casualty. I went ahead and checked all the tubes. All of them checked good except for the rectifier tube, which is here. I thought maybe that because I've had these 4-pin base tubes like this, especially rectifier tubes. I thought maybe it was a bad solder joint or broken wire inside here. The base was real loose, so I took the base off and then even checked the filament with the base off, and then it still was open, and there's no way I can show this on camera because this tube is too dark, but I got looking down inside the two plates and I actually spotted where the filament's open down deep inside. I can see the break. So this, even though it's a nice globe tube, it's got an open filament. It burned out. So I've got an 80 rectifier, just don't globe ones. So this will work. I actually got a couple more of these that are no good too. They're globe, but I'll probably put the base back on, soldered on, because it's a nice display, if nothing else. When you got these older tubes, it's, even if they're no good, you can still put them for display. So anyway, I wanted to let you know on that. But I'll when it's running, it'll have just a lot newer 80 rectifier tube in it. But the rest of the tubes tested pretty decently. The output tubes were just a tad bit weak, but they both were testing still in the green, still in the good, just really low. But I wasn't too concerned about that. They both test pretty much the same. But the RF tubes tested really good, and the detector and first audio tested good. So anyway, that's where we're at on this, and this has gotten really long because I talked too much, and so that's where we're at on it. And I guess I'll thank you for your comments, and you guys are really gracious and kind with them. I'm not sure how deserving I am on that, but it means a lot from a lot of you, because you guys made comments on the tuning condenser and how wonderful job it, how good it looked and everything, and all that stuff. And coming from a lot of you who also do videos, and I've watched your videos, it means a lot to me, because you guys are really great at what you do, and fine attention to detail and everything. So to have you say kind words about my work means a lot. So anyway, thank you guys for your comments and for watching and everything, and I'll see you on the next video.